Consider the graph of f of x equal 1 over x using the table of value. When x equal negative 1000, f of x equal 1 divided by negative 1000, that is negative 0.0001. And let's fill out this table. When x equals 0, 1 divided by 0 equal to undefined. Okay. So let's plot the graph. So the value that we can graph, that we can clearly see are these, right? So let's go ahead and make sure that we can see the value clearly. So negative 1, negative 1. Negative 0.1, negative 10. So that's very close to the y-axis. Then we get to negative 10. Okay. When x is equal to negative 10, the value is very, very close to 0. And so I can sketch the first part of this graph over here. Similarly, I can sketch the other part of the graph on the positive part. So here, this is the graph of f of x equal to 1 over x. Note that as the value of f of x approaches 0, as x approaches 0, as x approaches to 0 from the left hand side, you can see that the value of f of x, the value of y, increasingly bigger. Okay, so as x approaches 0 from the left hand side, f of x is increasing in larger and larger, so it approaches negative infinity. At the value of x gets closer to 0 from the right hand side, the value of f of x getting bigger and bigger, so that it increasing to positive infinity. So as x approaches 0 from the right, f of x is go to positive infinity. What happened to the value of f of x as x approaches plus or minus 0, plus or minus infinity? So let's take a look. The value of f of x as x approaches positive infinity, 1 divided by x, this value here getting larger and larger. Okay. And if that value is getting larger on the positive side, then 1 divided by a really, really big positive number, then it's approached to 0. And that value going to be positive. As x approaches negative infinity, similarly argument, you divide by a negative number, okay, and that negative is getting larger and larger to be the negative. So then this approaches 0 from the negative side. Now as you can see here, as x approaches negative 1000, right, the value of y is getting smaller and smaller, closer to 0, but it is on the negative side. Now if x is approaches 1000 or getting larger and larger, the value of f of x is approaches 0, but it is positive. So let's take a look at some new notation. So the symbol on the top, so in the first line we're reading this as x approaches a from the left, so this indicating left, and the positive here indicating right. Okay. One other thing to note is when x approaches infinity, it just said x getting to infinity, getting bigger and bigger, and that's it. To the positive side, if we didn't say, right? So increasing. So this technically is saying as x approaches positive infinity. Now, if you take a look at this graph that we have earlier, f of x equals 1 over x, note that the value right here, f of x, is increasing and decreasing around this value right here. This line, x equal to 0, is called the vertical asymptote. Of f of x equal 1 over x. Okay. So let's take a look at the vertical asymptote. The line x equal a is the vertical asymptote of the function y equal f of x. If y approaches plus or minus infinity at x approaches a from the right or from the left or from both. Okay, so here you can see that we have this case of infinity. Note that the graph does not intersect the vertical asymptote. We look in it here, we see that we have a horizontal asymptote. The line y equal b is the horizontal asymptote of the function y equal f of x. If y approaches b as x approaches plus or minus infinity. So here, as you can see, the graph can have an intersect at the asymptote. The graph may intersect the horizontal asymptote. So in our previous case, the horizontal asymptote is this line y equal to 0. So let's take a look at our first example. Describe the behavior of f of x near its vertical and horizontal asymptote. So let's talk about how do you find the vertical asymptote. So the vertical asymptote of the rational function can be found by let the denominator equal to 0. Let the denominator equal to 0. So this graph here have the vertical asymptote with x equal 2. So let's take a look at the graph of f of x and see what happened to f of x as x approaches 2 from the left side. So as x approaches 2 from the left, and think about this, f of x equal to x divided by x minus 2. So if x approaches 2 from the left, this value go over here is a little less than 2. This implies the value of x minus 2 is going to be negative. Okay, so this means it is going to be a small number and it is negative number. This leads to this value f of x here is approaching negative infinity. Okay, so as x approaches 2 from the right hand side, then f of x is equal to x divided by x minus 2. And this value x in this case is a little more than 2. This means x minus 2 is going to be a small positive number. This means the value of f of x then approaches infinity at the asymptote. So what about the horizontal asymptote? Let's talk about the horizontal asymptote. Of f of x equal x divided by x minus 2. Let's take a look at as x approaches positive infinity. As x approaches positive infinity, then f of x equal x divided by x minus 2. The behavior of this, let's say if this value gets really large, then this value minus 2 really does not make much of the difference. So let's say if you have $1 million and then you give somebody $2, it's effectively you still have $1 million, right? So this minus 2 here does not really affect much the value of the function at all. So this telling us this is going to 1. Okay, so what happened when x is approaching negative infinity? So as x approaches negative infinity, f of x equal to x divided by x minus 2. Again, so if you owe somebody $1 million and you pay them back $2, that doesn't really make much of the effect. So then you still owe them $1 million regardless, right? So this value here doesn't really affect the denominator at all. It's telling you that the deciding factor here is still this value x. So then this still going to 1. This means this telling us that y equal 1 is the horizontal asymptote of f of x. Let's take a look at the next problem. So in order to find the vertical asymptote, I set the denominator equal to 0. So then x is equal to plus or minus 1 in this case. Okay, so here we have 2 vertical asymptotes. So first one, at x approaches negative 1 from the left, f of x equal to 2x minus 3 divided by x squared minus 1. The denominator here in this case going to be negative. And the numerator, well, at x approaches negative 1, the value 2x going to be negative. This leads to the numerator being negative. So then this approaches positive infinity. So as x approaches negative 1 from the right, f of x is equal to 2x minus 3 divided by x squared minus 1, the denominator is going to approach positive, okay? Because negative 1 to the right is a little larger than 1. A little larger than 1 square, then still a little larger than 1. So this right here is a positive number that is larger than 1 by a little bit. Okay. Then the denominator is going to be positive, but the numerator is going to be negative. This leads to your vertical asymptote is going to negative infinity. In the second case, as x approaches 1 from the right, f of x is equal to 2x minus 3 divided by x squared minus 1. So let's start with the left first. From the left, okay, if x approaches 1 from the left, well, 1 from the left is a little less than 1. So then this right here is less than 0. 2 multiplied with a number that is a little less than 1. Okay. This number right here is still being less than 3. So then this here is still being negative. So this is still going to positive infinity. As x goes to 1 from the right, f of x equal to x minus 3 divided by x squared minus 1. The denominator here is larger than 0, but the numerator is still less than 0, so then it approaches negative infinity. Okay. Now, let's talk about the horizontal asymptote of f of x equal to x minus 3 divided by x squared. Divided by x squared minus 1. So as x getting really large to positive infinity, then the behavior of this function is then being determined by these value, right? Because negative 3 and negative 1 does not really affect the value of the function as x getting larger and larger. This then telling me that the behavior of f of x is slowly depend on what happened to 2x and x squared. This means f of x is equal to 2x minus 3 divided by x squared minus 1. If it go to positive infinity, this then just really become 2x divided by x squared. This is the same as saying 2x divided by x, right? And as x getting really large and being positive infinity, this telling me that this is going to 0 from the right side. So what happened when x approaches negative infinity? Well, then f of x again slowly depend on the behavior of this, right? But when x go to negative infinity, you are looking at this being a negative number. So then this approaches 0 from the left. In either case, it will tell us that the horizontal asymptote y is equal to 0.